everybody. So it's Miss Abney, and we're here today to go over example 1 from lesson 1-5 from topic 1. And we've gone into solving equations, looking at these things and how to solve equations in a graphical form. And this problem says, how can you use a graph to solve an equation? So we're going to look at this equation. 3x plus 20 equals 5. Let me hide this. And then we're going to use the graph to solve this. So the first thing I'm going to do is this time we've talked about doing this by hand, but for this one, I'm going to show you Desmos. It's actually a great tool. So I'm going to go to your tools. I'm going to go to Desmos. When we get back to the classroom, you will need a TI graphing calculator. The one that I will use on my computer is a TI-84, but a TI-83 would work. Nspire will not, so make sure that you have that as we wait for Desmos to open. And this is a great graphing tool that you can use now that you are at home. All right, so we're going to put our equation. We actually have two different expressions here. So an equation, you need that equal sign in between. An expression is what makes up the equation. So on this side, we have one expression. On this side, we have another. And with these expressions, what I could do is I could say f of x is equal to negative 3x plus 20. And then the other one I have, I'm just going to call it g of x. And this is equal to 5. So what we're going to do is we're going to look at when f of x is equal to g of x. And we're going to look at this graphically. Later on, we'll learn how to do this algebraically, but when I say I want to see when f of x equals g of x, I'm going to see basically when they intersect. So let's go to the graph, and let's type this in. Negative 3x plus 20. And then the second graph is going to be 5. Where did my 5 go? Y equals 5. Let's see if that works. Yeah, there we go. So I was just playing with that. Y equals 5. All right, so the solution to this graph is we're looking when both y values equal each other. And looking at this graphically, I can see at this moment here that y equals 5 on both graphs. Right here, my value is 5. And so what x value does this occur at? Because we're solving for x. We need to find the x value where this occurs at. So looking at this, both of them cross or intersect at x equals 5, y equals 5. So for this one, I would say the solution for this is x equals 5. So f of x equals g of x when x is equal to 5. And if I really, really wanted to test this, if I really wanted to see if this really does work, I could plug 5 into this. Negative 3 times 5 plus 20. That's negative 15 plus 20, which is 5. So there is the work for this first part. So again, they're graphing. They broke it out into two different equations. They graphed both the equations, just like I did. And it appears that y equals negative 3x plus 20 at y equals 5. And they both intersect each other, not the x or y axis. They both intersect at x equals 5. By substituting the value into the original equation, you can verify the results. So we would say that negative 3x plus 20 equals 5 when x is equal to 5. Looking at this is a linear function. We're not going to have a max or min. This is a constant function. There's no max or mins or other places where the graph could cross. And so we only have the one solution. We have the left equation equals the right equation, only at the point where x equals 5. All right, and at that point, that's when y equals 5 as well. Okay, how can you use the graph to solve an equation? So we're going to solve x, the absolute value of x minus 4 equals 1/2 x plus 1 by graphing. Again, I'm going to break this up into two different equations. This is going to be, or two different expressions. This one's going to be f of x. So f of x equals the absolute value of x minus 4. This one is going to be my g of x. This equals 1/2 x plus 1. And what we're going to look for is when f of x is equal to g of x. So again, I could make a t-table if I need to do this by hand. And kind of more like an awkward h-table. And I could put in my x values, my f of x values, my g of x values. And I could do it, I don't know, like -1, -2, -3. Oh, I'm going the wrong direction. -1, 0, 1, 2, 3, 4, or other values. And then you plug these values into the equation. So that's -5, so that's 5, and then 4, and then that's going to be 3, 2, say that's 1, and then 0, and then so on and so forth. And then you plug this one into this equation and you find all the values, and then you could graph it that way. Or we could go over to Desmos, and again, use some of the tools that we have. I already have it open right here. And I'm just going to type in those new equations. Now, I don't know how to do the absolute value. So I'm going to go down here and I'm going to pick that keyboard. And right here are your absolute values. Okay, so we're looking at the absolute value of x minus 4. Put that aside. X minus 4. And then we're going to do the second equation, which is 1/2 1 divided by 2 x, that's an s, x plus 1. In this case, we have the absolute value. So we know we come down to the vertex and then we bounce right back up. So there is a chance that we're going to have two spots where we're going to have our line cross. And in this case, we do have two spots, this spot and this spot. So we have intersections here and here. So let's see where the intersections are for x. So we have an intersection at the point 2, 2. So if you did your table, you would see right here that this would be also 2. And since these match, then you have a point of intersection. And that's a point of which, or one of your solutions. And then the next one is up here at 10, 6. Our table did not go to 10. But if it did, you would again see 10 and a 6 and a 6. Okay, so the solutions to my problem, because again, we're solving for x. X is our variable in here. So I'd say f of x equals g of x when x is equal to 2 and x is equal to 10. So there's two places here where, or there's two x values here where we could have a solution to our equation. And again, if you have any questions, please post them in the classwork comments and I could answer them. So again, they broke it out into two different equations, and they intersected x equals 2 and x equals 10. So the solution for this is two solutions, x equals 2 and x equals 10. And then again, you could verify this by substituting them back in. And that's a really good practice to do. So let's substitute it back in. So I have the absolute value. Oh, sorry. I have a little button on the side of my pen. And sometimes I just hit that. Does this really equal 1/2 times 2 plus 1? So 2 minus 4, that's going to be -2. Equals, that cancels that out. So it's 1 plus 1. So 2 does indeed equal 2. My face went gray. And then let's try the 10. So 10 minus 4 equals 1/2 times 10 plus 1. That's going to be 6 equals 5 plus 1, which is 6. So 6 equals 6. That is true. So plugging it back in, we do get the right answer. We did have the right solutions. All right, so now you're going to try it. So use the graph to solve the equation. Again, here in Desmos, they give it to you the way you need it, and you just type it in just the way you saw me type it in. And then you could check your answer, but you're doing 5x minus 12 equals 3. So think of what we did in that first part. And then the next one is use the graph to solve the equation. So this is kind of like that second part that we did. So again, if you have any questions, please leave them in your classroom comments. And the next video will be for example 2.